Hi, VencoreWeather.com meteorologist Paul Dorian here. Well, it's the middle part of October, time once again for the winter outlook for the Mid-Atlantic region. Anytime I'm dealing with long-range weather forecasting, I first like to take a look at oceanic temperature patterns around the world. As we all know, the atmosphere can change quite quickly from hot to cold or cold to hot in just a matter of minutes or hours, whereas the oceans take a much longer time to warm up and cool down. What you see right now in terms of sea surface temperature anomalies around the world can certainly continue to exist 2, 3, 4 months from now. So that could be a useful tool in any long-range weather forecasting task. In addition to the oceanic temperature patterns, we will focus in on an atmospheric phenomenon called high latitude blocking. There actually are 3 signals that involve the Arctic Oscillation Index, the snowpack across the northern hemisphere, and the solar activity that's going on right now on the sun. All 3 of those favor high latitude blocking episodes. This is an important feature in terms of the temperature forecast for the northeastern U.S. in any given winter season. Finally, another useful tool for long-range weather forecasting is to go back and find analog years that have sea surface temperature patterns similar to today's environment. You're never going to match exactly, but if you can find some years that had similar sea surface temperature patterns, especially across the Pacific Ocean, that can provide useful information in any winter outlook for the Mid-Atlantic region. I have listed here the key factors for the upcoming winter season. The first 3 involve oceanic temperature patterns. A strong El Nino is occurring right now in the tropical Pacific. That'll certainly play a big role in the upcoming winter season. There's a warmer than normal sea surface temperature pattern continuing to exist. It has persisted for the last couple of years in the northeastern pattern, in the northeastern Pacific. That too will play a big role in the winter season here in the northeast U.S. Finally, in terms of oceanic temperatures, there's a warmer than normal sea surface temperature pattern right now just off the East Coast that played a role in the intensification of Tropical Storm Joaquin. Ultimately became a Category 4 hurricane. I believe there will be numerous coastal storms this winter, and the warmer than normal sea surface temperatures will act to enhance those coastal storms in the I-95 corridor during the upcoming winter season. Also, the high latitude blocking atmospheric phenomena will look at 3 signals that favor high latitude blocking to occur on an occasional basis, perhaps a frequent basis in the upcoming winter season. Finally, we talked about analog years. These are 6 years that have similar sea surface temperature patterns. By looking at what kind of winter those analog years had, that can provide us with some useful information for trying to predict this year's winter in the Mid-Atlantic region. Well, let's first start off with the sea surface temperature anomaly map of today. This comes from tropicaltidbits.com. A couple of things jump out at you right off the bat. First of all, lots of orange and red right here in the tropical part of the Pacific Ocean. This is a strong El Nino event. It rivals some of the strong El Nino events of the latter part of the 20th century, 1972 to 73, 82 to 83. 97 to 98. We typically had a strong El Nino event maybe once a decade in the latter part of the last century. The first decade of this century did not really have a strong El Nino like this, but rather it had 3 moderate strength El Nino events in 02, 03, 06, 07, and then again in 2009, 2010. Again, this will be a key player in the upcoming winter season here in the Mid-Atlantic region. Notice also lots of orange and red just off the west coast of the U.S. and along the Alaskan coastline and just off the west coast of Canada. This has been a very persistent blob of warmer than normal water, and it looks like it will continue into this winter season as well and play an important role in the upcoming winter weather here in the northeast U.S. Notice also an area of warmer than normal waters in the western Atlantic. This will play a big role in the enhancement of what I expect to to be numerous coastal storms along the I-95 corridor. A week or so ago, we had Tropical Storm Joaquin that intensified rapidly into a Category 4 hurricane, partly enhanced by these warmer than normal waters off the east coast of the U.S., a persistent pattern that should continue in the winter season. Well, we just took a look at the current sea surface temperature anomaly map. What about the forecast? We'll look at two independently made computer forecast maps for the sea surface temperature pattern in December, January, and February averaged together. This comes from NOAA's CFS V2. Notice strong El Nino continuing here in the winter season. Strong warmer than normal sea surface temperature pattern in the northeastern Pacific, and strong warmer than normal temperature pattern here in the western Atlantic, as predicted here by this CFS computer forecast model. Notice also the highest temperatures relative to normal in the El Nino during the upcoming winter season are predicted to be in the central part of the Pacific rather than the eastern part of the Pacific. This is a crucial point to factor in here. I do believe it'll be more of a centrally based El Nino. Centrally based El Ninos tend to allow for the development of a ridge in the upper part of the atmosphere along the west coast of North America, and that in turn allows for some cold air outbreaks to reach the northeastern U.S. El Ninos based in the eastern part of the Pacific can flood the eastern U.S. with warmer than normal temperatures. Again, I believe the models point to, and I believe the latest sea surface temperature changes in the Pacific Ocean point to a centrally based El Nino during the upcoming winter season. Well, here's another computer forecast map. Well, this one comes from the Japanese Meteorological Agency. It's called the JAMSTEC model, and it actually does pretty well in El Nino years. This is the sea surface anomaly map for December, January, and February averaged together, and again it points to a centrally based El Nino in the tropical part of the Pacific Ocean. Also, it points to warmer than normal waters continuing through the winter season off the west coast of the U.S., off the southwest coast of Canada, and the southern coast of Alaska. It does not, however, have warmer than normal waters in the western Atlantic. This particular model tends to dissipate that warmer than normal water. I don't really agree with this. I tend to agree with the previous model, the CFS V2, which continues the warmer than normal water pattern in the western Atlantic. That has been so persistent, and it's hard to see that dissipating over the next couple of months. But in general, this model agrees with the CFS model from NOAA, especially in the Pacific Ocean, in that it looks like a centrally based El Nino, and the warm blob in the northeastern Pacific will continue to exist. Not shown here, but also in agreement with a centrally based El Nino is the UK Met model. That comes from the United Kingdom. That too has the centrally based El Nino in the tropical part of the Pacific Ocean for the upcoming winter season. Well, we talked up front about the usefulness of analog year forecasting, going back in time to find some analog years that feature the same sort of or similar sea surface temperature patterns to what we see today. These are the 6 years that I found. Main characteristic amongst these 6 analog years is that there was at least a moderate and in many cases a strong El Nino event. 1997 to 98, 91 to 92, 82 to 83, 57 to 58, 2009 to 2010, and 1986 to 1987. A couple of points to make here. 1972 to 73 did feature a strong El Nino year, but I do not call that an analog year because the northeastern Pacific was much colder than what we see today, so I did not use that. Also, 09 to 2010, a very snowy year in the Mid-Atlantic region, and finally the other couple of years with very strong El Ninos, 82 to 83 and 97 to 98. The winter season of 1982 to 1983 actually was a warm winter in the northeastern part of the country, but it had a blockbuster snowstorm in February of that year. As anybody knows who lives in the northeastern U.S. and loves snow, 100 things have to go together for a snowstorm in the big cities of Philly, D.C., and New York City. And one of those is sustained cold air, and that occurred during February of 1983, led to a major snowstorm. In fact, the biggest snowstorm at that time in Philadelphia, where up to 2 feet of snow fell with thunder and lightning. That is one strong El Nino winter season that featured a blockbuster snowstorm. I believe those types of blockbuster snowstorms are on the table for this year. Well, what kind of temperature pattern existed on average for those analog years? Here we see much warmer than normal across the northern U.S. and colder than normal in the deep south. Not too atypical for a strong El Nino year. Now, importantly, the Mid-Atlantic region kind of sandwiched in between those two zones, with near normal to perhaps slightly warmer than normal in the December, January, and February time frame. And this is the pattern that I do see happening during the upcoming winter season. Again, near normal to slightly above normal in the I-95 corridor of the Mid-Atlantic region. This will be a major change for the winter in the upper part of the Midwest. Places like Chicago, Illinois, and Madison, Wisconsin suffered through brutally cold winters during the last couple of years. This year looks warmer than normal in the upper part of the Midwest and throughout much of the northern U.S. Well, before we take a look at the precipitation patterns for those analog years, there's an interesting finding with respect to the month-to-month temperature anomalies for those analog years. We have December's pattern right here in the lower left, January in the middle, and February in the lower right. The yellows, oranges, and reds represent warmer than normal temperatures in those analog years. For the month of December, it was quite expansive, all the way from the northern plains down to Florida. Notice, however, in January, that warmer than normal pattern shrinks. It kind of retreats back to the north and west, and even more so in February, featuring a normal temperature pattern here in the Mid-Atlantic region during February. What this tells me is that, first of all, a couple of things. December could turn out to be a mild month here in the Mid-Atlantic region, but the tendency will be for progressively colder weather as the winter season goes on, certainly progressively colder relative to normal. And in turn, that leads to the possibility that the worst of winter will be during the second half of winter, maybe the latter part of January into February and March. So quite an interesting finding for those analog years that certainly can apply to the winter outlook in the Mid-Atlantic region. Well, how about the temperature pattern for those analog years? The blue on this particular map that comes from NOAA represent wetter than normal conditions for the December to February time frame. Notice from the west coast across the deep south and up along the eastern seaboard, a wetter than normal precipitation pattern. And I believe this is what will occur. A strong El Nino, especially a centrally based strong El Nino in the Pacific Ocean, tends to pump a lot of extra moisture into the southern branch of the jet stream. It actually tends to enhance the southern branch of the jet stream, which typically in wintertime will bring storms across California into the deep south and then up the eastern seaboard. California could certainly have an alleviation of the drought this winter with numerous storms. The deep south can have some above normal precipitation with storms moving from California to the east coast. And then finally, numerous coastal storms can be expected this winter season, not only with El Nino in the Pacific Ocean, but also with the warmer than normal sea surface temperature pattern in the western Atlantic. During the wintertime, the land mass here in the U.S. is cold, and there's a natural temperature gradient that forms in the wintertime between the relatively warmer waters of the western Atlantic and the cold land mass. Anytime the waters are warmer than normal, that will intensify that temperature gradient along the east coast, and that in turn will tend to enhance coastal storm development, and that's what I expect to see during the winter of 2015-2016. Well, so far we have focused in on oceanic temperature patterns. How about high latitude blocking? High latitude blocking is basically a phenomenon whereby high pressure dominates the scene, perhaps for several days at a time in places in the northern latitudes like Greenland, Iceland, northern Canada. High latitude blocking is kind of an essential ingredient to get cold air in the northeastern U.S. and, more importantly, sustained cold air. If you have a cold air mass without high latitude blocking, a coastal storm could certainly push that cold air out in a hurry, perhaps with all rain or maybe some snow changing to rain. Sustained cold air associated with high latitude blocking is kind of a requirement around here for snowstorms in the wintertime. And there are three signals that tend to suggest the likelihood for high latitude blocking in the winter season. One of those is called the Arctic Oscillation Index. Meteorologists use this particular index along with its closely related cousin called the North Atlantic Oscillation to track high latitude blocking. And basically, when the AO index is negative, you have a high latitude blocking situation. If it's positive, you tend not to have high latitude blocking. And studies have shown that if the AO index is largely negative during the preceding summertime and autumn season, then the subsequent winter season is likely to have predominance of negative AOs. And indeed, this is the neutral line right here. Notice lots of negative AO indices from July right through October. In fact, July averaged out to some of the lowest, most negative AO indices in the past 50 years. And any July that is in the top 10 in terms of negative AO had dominating negative AO during the subsequent winter season. Notice also right here in the past week or so, quite a drop in the AO index to some of the lowest levels, most negative levels in the past several months. So this particular index is a bullish signal for high latitude blocking in the upcoming winter season. Well, some research studies have shown that snowpack across the northern hemisphere this time of the year can be used as a predictive tool for whether or not high latitude blocking will occur, specifically if the snowpack is above normal, especially in places like Siberia. Then that tends to lead towards the more frequent high latitude blocking scenario in the wintertime across the northeastern U.S. and across northern Canada, Greenland, or Iceland. This particular map comes from the Rutgers Snow Lab, which is a great website, and it shows the snow cover anomaly chart at the end of September for the entire northern hemisphere. Notice above normal right here. The normal line is cutting across right here. This end of September featured above normal snow, not quite as dramatic as a year ago at the end of September 2014, but nonetheless above normal. And now let's take a look at what's been going on across Siberia during the month of October. Well, what we have here are two maps that show the snow cover, one at the end of September, September 30th, and the other just now in the middle part of October. This is Siberia, this region right here. The white here represents snow cover. Notice the dramatic increase in the past couple of weeks. This is a bullish signal for high latitude blocking for the winter season. Some studies have shown that the specific region south of 60 degrees north in Siberia, the snowpack during the month of October can be a good predictive tool in terms of high latitude blocking in the subsequent winter months. And indeed, any kind of an expansion that occurs in that part of Siberia is usually a bullish sign for high latitude blocking. And as you can see, again, the snowpack has increased quite a bit in the first half of October. Again, this is a bullish sign for high latitude blocking. By the way, notice also across the pole here in the northern part of Canada, quite a change, quite an increase in snowpack here compared to late September to the current conditions right here. this filled in across the northern part of Canada as well. So the snowpack provides us with another bullish signal that high latitude blocking can indeed occur, perhaps on an occasional or even a frequent basis this upcoming winter season. Well, there is one other signal that studies have shown can be quite useful in terms of predicting whether or not high latitude blocking scenarios will occur in a winter season. Believe it or not, it's related to the sun. Low solar activity years tend to feature high latitude blocking situations in the winter time. This is a composite map using analog years of low solar activity years during solar minimum phases of many of the recent solar cycles. And what we're looking at is the height anomaly chart at the surface, which shows these yellow and orange and green areas higher pressure than normal. And notice right here, across Greenland and Iceland, higher pressure than normal in these low solar activity years. This is a high latitude blocking type of situation. Lower pressures here across the northeastern U.S. in these particular years. So this is another thing to look at. Again, it's seems to be a bullish signal right now because we are in fact in a low solar activity year. In fact, let's take a look at a map right now that shows how weak the current solar cycle is. Well, the question is, will we have low solar activity during the upcoming winter? Well, we are currently in solar cycle number 24, seen right here on a map that also includes the sunspot numbers for the previous two solar cycles, 23 and 22, going back to the 1980s. And this is headed to be one of the weakest solar cycles in more than a century. We virtually had a spotless sun a week ago. I do expect low solar activity will continue over the next few months. We are now seemingly past the solar maximum phase of solar cycle 24. It looks like it peaked right around this area right here. So we are now headed down towards the next solar minimum. All of this favors low solar activity to continue in the December, January, and February time frame. And again, low solar activity has been correlated with high latitude blocking scenarios. So yet again, another bullish signal for some high latitude blocking events during the upcoming winter season. Well, now that we've discussed the oceanic temperature cycles, the atmospheric phenomenon called high latitude blocking, and we took a look at the analog years, what is the bottom line? Well, here's the bottom line in terms of the winter outlook for the Mid-Atlantic region. I believe that the temperatures will average out in the December, January, February time frame to be normal to slightly above normal in this range. And despite that, there will be occasional cold air outbreaks, Arctic air outbreaks that will tend to be sustained because I do expect some high latitude blocking situations to develop. So again, even though the overall winter looks like it'll be near normal to slightly above normal, there certainly should be some occasional significant and sustained Arctic air outbreaks into the northern, northeastern U.S. I believe there will be numerous coastal storms this particular winter season, partly due to the El Nino in the tropical Pacific, and there certainly can be a blockbuster storm or two similar to some of the other strong El Nino winters, such as February of 1983. What do I mean by a blockbuster? Well, that could be 2 feet of snow from D.C. up to Boston, one of those kind of situations. That, of course, in a hurry would put us at above normal snow levels for the big cities. Nonetheless, this is the forecast map, the forecast for the snowfall of at least 20 to 30 inches in D.C., 30 to 40 in Philly, 35 to 45 in New York City, even more in the suburbs. And again, this is all above normal. And part of that is because of the numerous coastal storms that I expect, along with occasional Arctic air outbreaks. Finally, as we discussed earlier, it looks like the worst part of winter will occur during the second half of the season, latter part of January, February into March. Even possible that December turns out to be a mild milder than normal month. So quite an active winter coming for the northeastern part of the country. We'll, of course, continue to follow all of these key factors over the next several weeks here at VencoreWeather.com. That's it for now, and this has been the 2015-2016 Winter Outlook for the Mid-Atlantic region by Vencore Weather. We'll continue to monitor all of this over the next several weeks.